So as I said in the previous recording, now I will continue on the rotation of a rigid body. So the famous unit for rotation is, it's not a unit, but we generally use the RPM. What it means is that it means the revolutions per minute. Okay, this is the famous dimension, you can say, that we use for rotation. And then one revolution is 2 pi. So what it means is that, so it starts here, it makes full circle. Okay, and as you can see, it is 14 RPM. What it means is that it makes 14 revolutions in 1 minute. The RPM we can also see in the car engine, that it shows like how many times the piston makes up and down cyclic motion in one minute. Okay, so this is the one famous one that we use, but then we also use that is radians per second. That's also the important unit that we use for rotations. So when the rigid body rotates, as you can see, it rotates this way in a circular motion and then about a fixed axis. And one thing I should mention is that 2 pi radians. Let me add it to make things clear. Okay, and then for a rigid body rotation, we have the theta, we have the omega, and then we have the alpha. And this one is very similar to that we have S. Let me use other color. We have S, we have the velocity, and then we have the acceleration. And this one is for a particle, and this one is for a rigid body. And then for all of these, the theta, the omega, and then alpha, these are all vector quantities. Okay, so you have to be very careful here. And these vector quantities, as you can see, as you will see, so mostly we will use a cross product. Okay, and then you have to review the cross product and then how we do the cross product. We have to review it. So if you have an I component, and then if you have a J component, if you have a K component. So let me just show a simple. So if you cross I with the J, if you cross I with J, then you will get K component. If you cross J with K, you will get I component. If you cross the opposite, J with I, you will get negative K. The other combinations are 0. So if you cross I with K, you will get negative J, but if you cross I with itself, you will get 0. Anyway, you have to review so this part of review, this is up to you, okay? To review this cross product section and then see how it works. And then you can see that the theta, this one is angle. Okay, and similar, this one is displacement and this one is the angle. And then the omega is the angular velocity and then alpha is the angular acceleration. So let me add it here. So you have the angle and then change of angle with respect to time, that is angular velocity. Okay, and then change of angle with respect to time, but again that thing with respect to time. Okay, and this one is the angular acceleration. In next slides we will talk about more, but we generally use the right hand rule. Here we will have a couple of formula, so that's the reason that I will do a separate recording for this one.